This is a flipped video for graphing a quadratic inequality. So first thing we need to do is we need to review what we do when we are graphing inequalities. The first thing we need to note is that depending on the type of inequality, we will either have a dotted line or a solid line. When we have inequalities that are written as less than or greater than, we have dotted lines to indicate that these points on this line are not being included in our shaded portion of our graph. We also have solid lines, and those are indicated by the less than or greater than symbols, and that tells us that these lines are being included. The steps we use for graphing parabolas that are inequalities is first we sketch the graph using the equation y is equal to ax squared plus bx plus c. So we think of this as being an equality instead of an inequality for the moment. When we draw our line, we first note whether or not the line should be dotted or solid. Notice that when we draw our parabola ends up being divided into two regions. And what this looks like is that we have one region that is inside of the parabola, and then we have another that is outside of the parabola. So all this region that is outside of our curve. And now what we want to do as part of our second step is we want to choose a test point based off from our graph that is not included on our parabola to determine which area is being shaded. So from the example that I've just drawn, one point that I might choose to test is this point here at the origin, since it is small numbers, and 0, 0 is easy in general to plug into an equation. And so what this does is we plug in these x and y values, and then we decide whether or not it creates a true statement. If this statement is true, then we graph in the area that includes the dot. So if this statement ended up being true, I would graph inside of this region. If it was false, then I know that it isn't part of our solution and must then be shaded on the outside. So let's look at how this works by graphing an inequality. Notice we have y is greater than 3x squared plus 6x. Since we have the symbol greater than, this tells us that our lines are going to be dashed. So I'll make a note here that we're going to have dashed lines. Now, we're going to find our axis of symmetry, and as a reminder, we do this by calculating using this formula, x is equal to negative b over 2a. And when I plug in my b and my a values, I have b is equal to negative 6 divided by 2 times 3. And this gives me the value negative 6 divided by 6, which is just negative 1. So my solution, or for my axis of symmetry, is x is equal to negative 1. So then I can use this to find the coordinate of my vertex. And I get this by plugging in my negative 1 into my equation. So I think of this for the moment as being the equation. And I get y is equal to negative 1, or sorry, that's negative 1 should actually be 3x, 3 times negative 1x, or negative 1 squared, plus 6 times negative 1. So solving for this, I get 3 times negative 1 squared, which is 3, times 6 times negative 1 is negative 6. So 3 plus a negative 6 is a negative 3. So for this problem, our vertex ends up being -1, -3. Now I can find my y-intercept, which we're going to place here in place of our x-intercept. So we're going to find our y-intercept, and that is determined by our c value. Our x must always be 0, and our c is determined by the number located on our inequality. But here, notice there is no c listed, so we know that we must be adding 0 to this, thus making our c value 0. And so we have y-intercept located at 0, 0. So I now have 2 points to plot on my graph. I have 0, 0, and I have -1, -3. So I want to choose one more point, and I'm going to pick the point -2. And so plugging that into, for my x values, I get y values 3 -2 squared plus 6 times -2. And that gives me the y value 4, or -2 squared, which is 4, times 3, which is 12. And 12 plus 6 times -2 is -12. And that gives me the value 0. And so finding another point, I'm going to choose the value +1. When I plug +1 into my original equation, I get y is equal to 3 times 1 squared plus 6 times 1. And this gives me the values y is equal to 3 times 1 squared, which is 3 plus 6. So this gives me y is equal to 9. So here I have enough points that I can now graph. Since both of these bring out a y value of 0, they're actually going to be reflections of each other. But I can begin by putting in my axis of symmetry, which is located at -1. So I'm going to draw that in right here. I now have the points 0, 0, which is located here. And I have the points -1, -3, which is located right here. And I have -2, 0, which is located here. And I have 1, 9, which is 1 to the right of 1, 2, 3, 4, 5, 6, 7, 8, 9. And that gives me this point here. I can reflect this point across by noting that it is 2 to the right of the axis of symmetry, so I can move 2 to the left, and that gets me my last point here. So before I graph, I want to look back to my original equation, and I noted before that this must be a dashed line. So plotting this, we don't want these points to be included as part of our solution. So we dash them, and they look like this. So our final step is now we want to pick a test point not lying on our parabola to choose which area is being shaded. So a point that I would like to choose is this one here, located at -1, 0. And I choose this point because it's easy to plug into my inequality, and it'll give me a solution then to decide whether or not this is the region inside the parabola that should be shaded. So when I plug this into now my inequality, I get the coordinate -1, 0. So y is our y value is 0, and then is greater than 3 times -1 squared plus 6 times a -1. So what this gives me then is 0 is greater than 3 times -1 squared, which is 1, is 3 times 1, plus 6 times a -1. So that's 3 plus a negative 6 or negative 3. So I get 0 is greater than negative 3. Since 0 is in fact greater than negative 3, we have a true statement. And since this is a true statement, I graph in that region. So this tells me that the region inside here is included as part of my inequality. So all of this area here. Okay, so now let's look at a second example where y is less than or equal to x squared plus 3x plus 1. Notice that this is less than or equal then, so this tells me that I am going to have a solid line. Let's note right away that my a, b, and c values are here, and we can use this to find our axis of symmetry. So using my equation, x is equal to negative b over 2a, I have negative 3 divided by 2 times 1. And this gives me negative 3 over 2. So my axis of symmetry tells me my x-coordinate of my vertex. So negative 3 over 2 is for my x value. And then I can plug that into my original equation then to find my y. I'm going to use purple for my y value. And so when I plug this in, for the moment I pretend this is an equal sign. And I get y is equal to negative 3 over 2 squared plus 3 times 3 over 2 plus 1. So what I can do now is I have two choices. Either I can leave this as a fraction form and finish this problem in that way, or I can rewrite this as a decimal so I can put it into my calculator. And so that's what I'm going to do. I'm going to write this as y is equal to 1.5 squared plus 3 times 1.5 plus 1. And when I do this, I get 1.5 squared. Fortunately, I've already put this into my calculator, and that gives me 2.25. So 2.25 plus 3 times 1.5, which is 4.5. Oops, that should be negative 4.5 plus 1. So negative 2.25 minus 4.5 is negative 2.25 plus 1, which is negative 1.25. So now I have my y-coordinate. I'm going to rewrite this in terms of my decimals. So that gives me negative 1, or negative 1.5 and negative 1.25. So now I can find my y-intercept, which is located at 0, and my c value, which is 1. So that's my y-intercept. So I have 2 points I can plot. I have negative 1.5, negative 1.25, and I have 0, 1. So now I can pick another point, and I'm going to pick the value of negative 3. When I plug that into my original equation, I get y is equal to negative 3 squared plus 3 times negative 3 plus 1. And that gives me the value of negative 3 squared, which is 9, plus 3 times negative 3, which is negative 9. And then, as a result, I have the xy coordinate of negative 3, 1. Notice again, I found two adjoining pairs. So I'm going to pick another point located at -2. So if I plug -2 in, I get y is equal to -2 squared plus 3 times -2 plus 1. And so when I solve for this, I get -2 squared, which is 4, minus 6 plus 1. So 4 minus 6 is -2, plus 1 is -1. So I have -2, -1. So now I have enough points that I can plot my graph. I put my axis of symmetry located at -1.5, so about 1.5 boxes over. And then I can plot my points. I have -1.5, -1.25, which is about 1.25 down here. And then I have the points 0, 1, which is located here. And I have -3, 1. And then I have -2, -1. So -2, -1 is located here, just a little bit above my vertex. So if I reflect that across, I go about half a block over. And so I have enough that I can plot my graph. Notice that we had less than or equal then, and we noted at the beginning that this is going to be a solid line. So I graph this, and this is what it looks like. So again, what I would like to do is I would like to pick a point that's easy to put into my equation to determine whether or not this area is shaded. So I'm going to pick this point here located at -2, 0. So right here, -2, 0. So when I plug that into my inequality now, I get my y is 0 is less than or equal to -2 squared plus 3 times -2 plus 1. And so this gives me 0 is less than or equal to -2 squared, which is 4, plus 3 times -2 plus 1. So that's 4 minus 6 plus 1. So 4 minus 6 is -2 plus 1 is -1. Notice that the statement says 0 is less than or equal to -1. But since -1 is smaller than 0, it is not greater, and this makes this a false statement. So since this is a false statement, that means that our area inside of where this point was is not included. So it does not equal, so it's not included. So what that means for us is now we have to shade the region that does not include that point, or this region outside of our parabola. So this is our area. So in conclusion, inequalities have dotted lines and they have solid lines. And this is a review from our previous units, but so do also quadratic inequalities. Our steps then for solving these inequalities is first, we sketch the graph using our methods that we've been practicing, and then we test a point that lies somewhere not on the parabola, and if it gives us a true statement, then we shade that region. If it is a false statement, then it has to be the region outside. So lastly, based on what we determined from our test point, we then shade our region. So that is all for this video. Remember to write your summaries.